Well, good afternoon and welcome to today's SEMA virtual education event. Today, we're going to be talking about bridging the gap from runs good to emissions certification. So what does that mean for you guys watching here? Well, if you're watching this, you're either a tuner or a calibration engineer or a member company who's interested in how we get our products ready for emissions testing. And I'm going to talk about some of the things that happen in between the normal high-performance vehicle shop tuning operation where we're just trying to get a car running decent in front of us today, and what needs to happen in order to pass emissions. And it's kind of a big gap, and it's a big lift for some companies to get from point A to point B. So we're going to talk about how we get there. So we start out with our modified cars. Thousands of tuners across the country, really around the world, are really adept at using commercially available software tools to modify the ECU to make the car run better after we've made changes. So our customers come in, they say, hey, I'd like a supercharger, or I'd like bigger injectors and a supercharger and a bigger camshaft. Great. We spend lots of time polishing this thing using all these tables that you see on the screen. And my favorite thing to hear from these guys is, I got done with all of it and it drives like stock. And raise your hand if you've heard that one before, right? It's a lie, because if it drove like stock, you wouldn't be here. Stock makes stock horsepower. Anytime we add power to these vehicles, we are now fundamentally changing how we're measuring that airflow, how we're getting at the appropriate amount of fuel, and what the appropriate amount of spark would be to go with it. So we've made quite significant changes to the calibration data that is inside that ECU that controls how that engine runs. And we need to. And part of that is to make our horsepower. Part of that is to get our customers something that is reliable and safe to drive. The engine's not going to have damage from an excessively lean air-fuel ratio or too much spark and getting into knock or any number of other potential issues that we could get into. That's great, but we're also on the hook for those tailpipe emissions. And so getting tailpipe emissions right requires a different standard of care. Number one, we have to do all the stuff that you see on the screen almost perfect if we're going to be passing Lev 3 emissions. So we have to do a really good job of controlling our air to fuel ratio and getting an appropriate spark. That's great, but how do we know it was right? And what are we up against if we don't get it? So that's what we're talking about today. So you've probably seen this memo from our friends in Washington, D.C. at the Environmental Protection Agency. And again, I'm your non-attorney spokesman, but I'll tell you that there's some key information in this. This memorandum that you see in front of you here dated back in 2020, but it supersedes the old Memorandum 1A, although fundamentally the lesson is pretty similar. They didn't make large changes, and we can go to the EPA website and we can read the entire document. It's not that long, and we can see in there. But what I want to point out to you is, from the EPA's viewpoint, they're looking at us as an industry of people who modify or tamper with validated OEM control systems. And anytime we do that, now it's on us to prove that our tampering isn't tampering, it's just modification, and that we didn't make the tailpipe any worse than it would have been without our touching it. Buried deep inside that document are a couple key points under their general notes. And I have highlighted two of them here because these are the really important parts. In the eyes of the EPA, by the absolute letter of what I see written in that document, it requires that our testing to prove that we are clean be done by somebody other than ourselves. So that third-party testing. Now, luckily, SEMA Garage qualifies here, and there's a couple other organizations out there that we've used along the way too that do the same thing, but it has to be a third-party lab, and that lab needs to be very complete. So buried in there, they're telling you it has to meet CFR 40 Part 1065. That little line right there means a lot. What it means is that every aspect of that testing is very tightly controlled. Now, fortunately, both SEMA garages, both in Diamond Bar and Plymouth outside of Detroit, meet this standard. So any test that is run there and passes there CARB and the EPA have agreed that, okay, well, that stuff's pretty good. Those guys are third party and they know what they're doing. They're pretty tight about how they run their tests. So if you get a clean result there, they're inclined to believe it. Now, they may audit us, but I haven't seen it happen yet. But this is kind of the far goalpost. So how do we get a passing result in this kind of condition? That's the question of the hour here. And so we start talking about what is a reasonable basis for assuming that the modification didn't make the tailpipe emissions any worse. Well, one way to do that is to just be the OEM. So if you're General Motors or Toyota or BMW, you've gone through and done certification in a lab. Now, they all have their own labs and they're allowed to self-certify, but they get audited a lot. They also send vehicles to the EPA. EPA checks vehicles. They have their own lab that looks just like that. Lots of great equipment there. And the OEM certification takes a long time, even after the vehicle is already clean. So before they get to that point, an army of engineers has spent probably about 2 to 3 years developing the vehicle and checking every little nook and cranny to make sure that the emissions and the drivability and the warranty is going to be good. It's a massive amount of testing over a bunch of different conditions. But if you go through all of that, you are now okay to sell the vehicle pretty much anywhere. And it's pre-title sales, which means that that condition can be done to the vehicle before it ever even gets sold to the customer. Now, what we do in the aftermarket, the key word there is after, is post-title work. So assuming the customer has already purchased a certified vehicle, they are now going to do a modification of some sort that has been blessed. That blessed modification is what the CARB EO process or the SEMA certified process hopefully gets us to. And it means that we've started with a OEM vehicle that was passing, and we made only a handful of changes and we certified again. But we do fewer tests than were required in item number 1 above. So these fewer tests go a lot faster. They're certainly a lot less expensive, but they're certainly not free. And we also have to go ahead and prove that we didn't break any of the diagnostics. And so we've got a tailpipe measurement and we've got diagnostics that work. And they look at that and they say, okay, we'll let you move forward. But again, easier said than done in some cases. We still have to get a vehicle that passes an FTP 75 or a USO 6 or an SCO3 test in a lab and comes up with a tailpipe number that is below the magic number for that vehicle. And that kind of leads me into that gray area. What else do we do here? And so if you are a manufacturer, so let's say you're ABC Supercharger Company, you're probably already very familiar with number 2 above, and you're probably doing that most of the time. The question is just how do we get ready for that ahead of time? Now, if you're not a manufacturer, but let's say you're an installer or a tuning shop, you live in this kind of gray area down below. And now I would love to see all of you guys go get your CARB EOs on every single package that you do, or get SEMA certified on every single package that you do, and every vehicle that leaves your shop gets the magic sticker. We know that's probably not reality because it's super expensive and time consuming, but there are ways for us to collect more information so that we can quantify if that tailpipe emission is generally good or generally bad. Gross polluters are pretty easy to locate, as we'll see going forward, but that's not good enough. We need to see a little bit more about it. And even OEMs and the manufacturers that are getting their EO or the SEMA certified are going to pass through this area. And so we have to collect some information here to have a pretty good idea of, are we clean or not? So if we do our homework properly and we clean the vehicle up and we run through that third-party lab and the resultant tailpipe number is below the magic standard and all the OBD works, then ARB will issue you a letter like you see here in the center of the screen, where they'll say, okay, your executive order number is now listed here, and you can go print stickers to put in your kits and put on the vehicle. So we've got a lot of member companies at SEMA who make certified products that have been through this process. And I wholeheartedly encourage you, if you are a manufacturer, if you make something that you can hold in your hands, that something should probably go through this process to give us a very good basis by which we can hand to CARB or the EPA should they ever inquire about our emissions compliance. But then there's that gray area. How do we get there? I don't want to show up to the SEMA garage not knowing if a new widget installed on a vehicle that may or may not have an ECU calibration attached to it is going to pass or not. Those tests are expensive. Let's face it. It's thousands of dollars just to get a failing number if you're not ready. So I don't want to do that. I want to do my homework before it's test time. So what can we do? I need some sort of measurement system that I can execute outside of that lab, because that every lab test is thousands of dollars. Well, I'm going to break a few eggs before I make this omelet. I need to go through and take some measurements and really start kind of using the chainsaw first before I start whittling, before I start using the sandpaper, and before I start polishing. So I need some equipment to kind of get me there. It needs to be easy to use. I need to have some sort of measurement. Fundamentally, I'm just trying to make sure that I get my vehicle clean enough that I'm not going to get fined for a Clean Air Act violation. That's what I'm really after. But how do I prove it? Well, I kind of got to get there. So there is a whole bunch of equipment that we can use along the way. And some of this you see here on the screen. It's kind of a spectrum, if you will. So on the far left-hand side here, we've got very basic stuff in terms of emissions measurement, one of which is the wideband O2 sensor. It actually tells us quite a bit about what's going on inside the engine. Below that, if we go to our AutoZone store, we can go inside and borrow their little handheld scanner, plug into the port under the dash, and see if there are any codes. Is that check engine light on or not? Has it completed the monitors? That tells me a fair amount. And vehicles that don't pollute should not have any codes. They should have run all their monitors and things should be passing. Cool. But then along the way, there's a bunch of different other equipment things in there. And you guys may recognize some of the devices you see on screen here in the middle. But as we get over to the far right-hand side, the little robot looking thing is actually a state inspection system. So it's actually quite similar to what you see in the bottom left as far as OBD inquiry. They just go in and they do a lot more inquiry. They'll look at some of your in-use monitoring and performance ratio data to see how often you've been passing. And they have some rather in-depth conversations with the manufacturers. If they see a certain make and model vehicle has trouble passing the EVAP diagnostic, for example, at a certain rate compared to its competitors, that may drive CARB, EPA, or various state agencies to go talk to the OEM and say, hey, you guys need to check out this truck and see why it's not setting the EVAP. And they have the ability to audit it. So on the right there, that white Ford pickup truck is actually in the new CARB lab in Riverside. Beautiful facility, state of the art, best of the best equipment in that place. And right underneath that, you'll see a 1065 compliant PEM system. We'll get to that in a little bit. So let's go back to that MIL for a second. MIL is a malfunction indicator lamp, or that check engine light on our dash. Working as an OEM calibration engineer in the field of diagnostics, we had pretty clear marching orders. They would tell us, you have to calibrate these diagnostics such that we wave the flag, which is the MIL light on the dash, if we have some stack up of conditions that would cause us to fail an emissions test by 150% of the standard. So we didn't just kind of tick past it by a little bit. We were 50% further along than we should have been. Now, most OEM systems try to target somewhere in the neighborhood of 50 to 70% of the standard for a good running vehicle. And so even at full useful life, their emissions should be well below whatever 100% of the standard is for that vehicle. So if it's LEV 30, that's LEV 3, 30 milligrams per mile of combined NMOG plus NOx. It's a pretty small amount of stuff coming out the tailpipe. So 150% of that would be 45 milligrams per mile. We're talking small changes here. And so let's say we had a bad sensor on the engine, and that sensor causes the engine to run rich. Well, obviously that's going to drive our hydrocarbons or NMOG up a bunch. And if it's enough to go 150% of the standard, we are required to turn on that light. So this relationship is really fundamental to the link between diagnostics and clean tailpipes. And so all these state inspection programs are basically relying on the calibration engineers in the diagnostic world to have done their job and gone and done all this testing. Remember, I was saying point number one earlier, where OEMs have this matrix of tests that they have to run across a wide range. Well, one of the things they have to run is what's called an OBD demonstration. So if you were the manufacturer of record, MOR, let's say you're Ford Motor Company, and you're certifying the Mustang, you have to demonstrate that when I induce a failure, and that failure makes the tailpipe emissions go up more than 150% of the standard, I must set the appropriate mil on the dash. And so I've induced the failure, I see the check engine light on, and then, oh, by the way, I can pollute all I want because the presence of the mil already waved the flag and said, hey, I did something wrong, fix my vehicle, bring it back to the dealership, find the problem and fix me so that my tailpipe emissions will come back in line. So same thing when we do our SEMA certified or our EO process, they look and see, is the check engine light on? If the mil is on for any reason, you failed, because those diagnostics are looking for things that are all contributing factors to making the tailpipe emissions worse. So when we do state inspections later on and they look for the mil or they look for stored codes, it's the same logic. And this is pretty powerful logic because I'll turn it around in just a moment here. So on the other side of that, we do a little bit of logic work here. And so my friend Aristotle taught me this once upon a time. He says, if the mil light isn't on and we did run the monitors, which means no trouble is shown, and I went looking for the trouble, well, then by logic, there should be no trouble, right? So this is the process by which they pass you in states that have the plug-in emissions test. So they don't bother doing a tailpipe sniffer anymore, because why have a sniffer when you got all these sensors on the engine and this powerful ECU running the engine that is constantly looking for failures? So as long as it's executing the search and the searches come up empty, and it's an unmodified system, by the way, then they will give you a pass and they'll say, okay, great, your pickup truck is good to drive for another year or two until you need to be inspected again. So that's cool. The only problem is that in the aftermarket, they don't always believe us because we are modifying. In their words, it's tampering, right? So we'll have to start talking about how do these diagnostics work. And so I open up my favorite software tool with aftermarket access, and I start looking at this and go, wow, cool. Look at this. I've got hundreds of different variables and tables of hundreds of values in them. And look at all this stuff I can move around and adjust. It's kind of comical because working on the inside and seeing how the sausage is made, the amount of tables that we see in our aftermarket tools is quite literally the tip of the iceberg. You might see a couple hundred tables in your laptop when you use commercially available tools. When you are working at the OEM and you have the spinal tap into the ECU and you have the complete support of the guy who wrote the software right down the hall from you, you realize that modern ECUs have upwards of 16,000 or more variables in there. And a variable might be a single number like you see on the screen here, or it might be a table that's 32 by 32. It still only counts as one. And so there's 16,000 plus of these in a modern ECU. That's a lot of stuff going on. And most of those are dedicated to diagnostics. So there's a lot of stuff. And even though we potentially have access to it, it's not all there. And again, like I said, these commercially available tools are both good and bad. So theoretically, if I didn't want the check engine light to come on, if I was a bad guy, and by the way, the EPA and ARB know this, I could just go in there and go to the master diagnostic test code list and start unchecking boxes. And if I uncheck the boxes, sure enough, the mil doesn't come on. And so it doesn't report the error. In fact, I can make it so the light doesn't come on and it does not report an error. Now, a lot of times these things report on the second error. So if there happens to be a little glitch in something, a loose connection or whatever, we'll wait till the next drive cycle and make sure that, that sensor is really broken. When it's consistently broken, we flag the mil. That's great, but theoretically you could turn this off if you were a bad guy using the software. And so a lot of these software aftermarket companies have specific training that they make you go through to make you aware that this is an absolute no-no on a street-driven vehicle. Now, if you are legitimately using this controller in a race car, and that race car shows up without a license plate in a trailer, we'll talk about that a little bit later, because that's the other area. That's RPM Act. That's the stuff we're talking about where we're going to save our race cars. But if this is a street-driven vehicle, this whole area of the software should basically be a no-no. We should not be turning these things off. If you turn these off, there are both civil and criminal penalties that can be applied if you get caught doing this stuff. So not only can they fine you, and the fines get astronomical very fast. I don't know if you guys have followed any of the consent decrees, but they like to throw a lot of zeros on the end of those numbers. And then, oh, by the way, there can be criminal penalties, especially if they find out that you were doing it on purpose and you knew better. So if you've been through training and we told you don't turn this off and you go ahead and turn it off, well, that was willful. And they start throwing around a lot of legal terms and it gets really ugly. And the short story is these can become felonies. So we're not talking about an overnighter if they get really angry and want to come after you. And remember, this is your government, so they have basically unlimited resources to investigate and prosecute if they really get angry about it. So the P codes are a big chunk of this. Also, within the logic, there are other things in there. So I highlighted in red things like catalyst protection or component protection, and that over temp protection. Well, that's a function that adds fuel to keep things from melting down, because catalytic converters are notoriously pretty warm when they operate. And we can get them even warmer by operating in different modes. So if we tip in, tip out of the throttle a lot, we go wide open throttle and we saturate them with fuel, and then all of a sudden we put some oxygen in them, they can get really hot really fast. They can get hot enough to melt. And there is logic inside the ECU to protect the hardware. So if we supercharge a vehicle, for example, we have the ability to put a lot more air and fuel down the pipe across that catalytic converter, and we can get it hotter than it ever would have normally gotten before. And if I'm dumb enough to go ahead and turn off the over temp protection, it would not be a surprise that we would melt the catalyst down. So going a little rich, oh, that's bad for emissions. Kind of, but you know what's really bad for emissions? A melted catalyst. So we don't want that thing to go to zero operation. So we've got these protection strategies. If we get rid of those protection strategies, the EPA and IRB look at that basically the same as turning off the check engine light for other stuff. It's a big no-no. So OBD functionality is absolutely not optional. So when you, again, look at the enforcement policy, and you see on the bottom, it says, this does not apply to conduct affecting the OBD system, which may be subject to enforcement regardless of its effect on emissions. So simply saying, well, it didn't make the emissions any worse for me to turn off that monitor. But you have to leave the monitor. The monitor has to be there because those state inspection systems are using those monitors to verify that everything else was working properly. And sometimes turning off one monitor has a cascading domino effect on other monitors downstream of it. So while you think you may have only turned off one thing, you may have turned off 5. So because of that, it's a big no-no to touch this stuff. And quite frankly, we can make lots of horsepower while keeping all of these OBD functions intact. So checking up on our OBD functions, well, couldn't be easier. There are $20 tools on Amazon where we can plug in and Bluetooth to our phone, and with a $2 or $5 app on our phone, we can read all the codes and see what's going on and see the mode 9 data, so we can see the history of how this car has been running. So mode 3 is the failures. That's just, is the check engine light on or not? But when we look and see, is the catalyst monitor complete? Is the fuel system monitor complete? This is the stuff that state inspections are looking at, so we can check it ourselves. I would not show up to a state inspection not knowing if I was going to pass or not, and I can check it for pennies on the dollar here just by putting one of these simple devices in there. Now, a lot of our favorite tuning software systems will also do this. So that's cool. And we should pass with this. If you can't get this stuff to pass, we need to clean our act up and kind of go back to square one and make sure, number one, we didn't turn them off. And number two, is this car running clean? Now, none of this is a direct measurement of pollutants is the downside of this. So even though we ran our monitors and the check engine's light is not on, that's enough to get your tabs renewed in a lot of states, but it's not enough to get you an EO. It's not enough for the EPA to give you a complete pass on it. So we need to do a little bit more homework. So more homework starts with simple tools. And again, I'm still kind of on the affordable spectrum here. So my favorite tool to start with is the wideband O2 sensor. So a lot of cars actually have these from the factory now, but we're going to have to find a way to measure the raw engine out. So even before we have a catalyst, I want to see, is the stuff coming out of the exhaust valve generally clean or generally dirty? Because the combustion system, bottom center here, is the most impactful part of the system when it comes to emissions. If I don't burn my fuel completely inside the cylinder and I leave leftover stuff going out the exhaust valve, that leaves a lot of cleanup work later for my catalytic converter or my after treatment system to try and clean up after the fact. So the cleaner I can make things coming out of the raw engine, the cleaner my tailpipe generally gets. Now, we have to assume that there is still a functioning catalyst back there. But when we take wideband measurements, we're looking at the engine out, not the tailpipe out. Later on, we'll look at some stuff that goes to the tailpipe. So these are pretty affordable. In fact, we can integrate them with a lot of our popular tuning software. The really cool thing is we get a very fast response. So if I tip in, tip out, I can see it on my wideband O2. So that's great. But once again, this is not a direct pollutant measurement. Yes, I see oxygen, I see lambda, but those are indicators. So we've all kind of seen the multicolored graph down here on the bottom to see, well, we've kind of got the bathtub for hydrocarbons, and we know carbon monoxide goes up when we go rich, and NOx, well, that kind of spikes in the middle. Well, that's a little tough. So I could think I'm really clean, but still make lots of NOx. This device doesn't catch it. And then, oh, by the way, misfires really confuse the heck out of an oxygen sensor. So we might need some additional measurements, but this is the cheapest tool other than the OBD readers, and it tells me a lot. It gives me that indicator of where to start looking. Now, if I want to get a little bit more specific, this is where things like the 4-gas and the 5-gas analyzers come into play. These used to be used on the old inspection standards. So if you ever had to certify with BAR 97 or IM 240, our GT 240 is actually still used in Australia in some cases. These devices will look at concentrations of hydrocarbons and carbon monoxide and CO2, and they kind of give us an idea of how complete the combustion is and is there any other bad stuff. So they generally work off of NDIR, so non-dispersive infrared spectra analysis, which is cool, but it's a little slow. So we not only have the delay between what comes out the engine and makes it down the length of the vehicle, but then we have to pull it through the sampling system here and have some absorption and processing time. So there can be as much as 30 seconds delay between what's happening here at this device and what's happening upstream at the engine. So if we're doing a steady state measurement, great, because the signal will stabilize. And so to that end, they're pretty useful tools. If I just hold the engine at 2000 RPM and 30% load, I just want to see, is it making lots of NOx or not? Well, this device will tell me. But if I'm going to drive the emission cycle and drive an FTP 75, for example, where I'm tipping in and tipping out and speeds and loads are changing, by the time it gets back to the tailpipe, it's hard to correlate a spike on this equipment with exactly where we were on the engine. And so that delay becomes problematic. It's better than no information, but it's going to take a skilled calibrator to start lining things up and making the appropriate changes. Now, the only other thing too is, by the way, these are, again, not a 1065 lab. So the NDIR measurement system is not what you're going to see at an EPA laboratory. So they use a completely different technology for measurement. And so as a result, again, these are just an indicator. But we can start to see what clean looks like and what dirty looks like. If we had clean combustion, the only thing we would have coming out the tailpipe would be CO2 and water. So this device could theoretically show you that. Going a step further, we get into this device here. Sensors Inc. makes this thing called the VMAS, and it uses ND-UV, so non-dispersive ultraviolet. It is more accurate than the 5-gas units. It's a little faster responding, but it's still a little bit more cumbersome. Now we're getting slightly more expensive here. So where the 5-gas analyzers might be a couple $1,000s a piece, $5,000 to $8,000 a piece, depending on what unit we get. This unit is, last I checked, around $60,000 plus or minus for one of these for a single channel. But the cool thing is now they do a known dilution. So they measure their flow, and with a known dilution and a relative concentration, they can now start to get an actual count, theoretically, of how many grams or milligrams of some bad things going out the tailpipe. Now we just have to start arguing accuracy. The cool thing is that this device, I've used it before. I did some work with Mustang Dynamometer. We made a video showing how everything can work together. The Mustang Dynamometer can drive those FTP cycles. So on the bottom here, you see the IM240, which is really just the first two hills of FTP 75. And we measure with a VMAS, and we can now start to get something that looks like the same standard that you would be measured against in the EPA lab, which would be grams per mile. So now we can start to see hydrocarbons or oxides of nitrogen in units of grams per mile. So that becomes pretty powerful, because now I can start saying, okay, where am I relative to the standard? Now, this is not the technology that if you pass on, they're going to give you a complete pass automatically, because they'll argue the accuracy. But this is pretty powerful. And again, if you know what a stock vehicle looks like on this, and then you modify, and then you do your calibration work, and you get back to the same or lower levels, well, now we're getting somewhere, because now we have a valid engineering comparison between clean and unknown to see what it looks like. And it's in those units of grams per mile, which is pretty cool. It's just not 1065 certified, so you couldn't submit this paperwork to CARB. But if I got to the point where I was looking squeaky clean on a VMAS, I'd be pretty confident walking into the SEMA garage and testing there on their CVS column. So next up, this is the mini PEMs. And I've been doing a ton of work on this over the last year or so. This is actually lower cost than the VMAS, because it's largely based off of ceramic sensor technology. And we're combining the ceramic sensors with some limited OBD data, and we're measuring concentrations of stuff coming out the tailpipe of the vehicle. So while I don't have a direct flow measurement, by combining with some smart processing of our data from the ECU using generic OBD data, we can start to learn a lot about what this looks like. And what we're finding is the signature of the vehicle. So by looking at a combination of measurements, we're really getting the emissions signature of the vehicle. And the EPA has written 3 different papers about this, talking about signature device testing. And I've got those right down in the green here in the center. There's a little bit of fine print, but if you look it up, those are SAE papers authored by the EPA scientists in Ann Arbor, Michigan, talking about how this is theoretically possible to get a good idea. Now, will they certify us based on this? Haven't seen it yet. I'd love to see it, because this is pretty affordable. I can set this up and I can run the test on a vehicle in under an hour. So there's no soak and prep. I don't have to drive exactly an FTP 75 to get this done. I can just kind of drive around in traffic, and I can take some measurements. And by parsing the data intelligently, I can start to get a pretty good idea of, is this vehicle generally good or is this generally bad? Beyond generally good and generally bad, what if I assigned a number to it? If I start assigning a number to it, well, then I can kind of make a sliding scale. And I know that brand new vehicles that meet the Lev 3 standard of bin 30, they're going to be squeaky clean. They're going to get a really high score. A vehicle that was only certified to, let's say, Lev 2 back in the late 90s, early 2000s, well, that might be a little bit dirtier than that. But a car with no emissions equipment whatsoever, that's going to get a really low score. And this kind of starts separating. But if I tested my vehicle using this mini PEMS in known clean state, and I know what clean looks like on this equipment, and I do my modifications. So I add a supercharger, add a camshaft, whatever I'm going to do, and I record using this device, and I keep sanding on my ECU calibration until that emissions signature from a similar drive cycle starts looking like the emissions signature from my known clean vehicle. Well, now I'm really getting somewhere. And the cost of this system is much cheaper. So for the cost of failing a few tests at a certified lab, I can run hundreds of tests on one of these systems and learn an awful lot about how clean or dirty my particular engine or vehicle or hardware combination might be before we ever start bothering going to the lab. So there's a little bit of setup time on this. I put it on the negative side saying it's about 20-minute prep time to get one of the sensors up to temperature because they tend to drift. But that 20-minute setup time in all practicality kind of goes away because that's how long it takes you to get the pipe attached to the vehicle and plug in and get all your other stuff ready and get the batteries in it and whatnot. So it's not bad. But I'll caution you, it's not a gram per mile measurement. So the number that you get off of this is not going to directly correlate with your lab reading for an EPA lab or going to SEMA garage or something like that. But it gives us that emissions signature. So it tells me, should this thing generally be closer to the clean side or closer to the dirty side? And I can start to kind of paint that picture and see what it looks like. So using the mini PEMS, one of my preliminary reports I've been playing with here is just, let's look and see what it did. So you'll see my general score, that bright red thing, point to, this vehicle was a 2013 Mazda Miata with a turbocharger on it. By the way, this car had 97,000 miles on the factory catalyst, so it's pretty much at full useful life. It was a Lev 2 vehicle. It was never really a Lev 3. It wasn't super squeaky clean. So getting a score of about 74, that's kind of like getting a C in engineering school. Well, is the C a passing grade? Getting pretty close here. I might roll a dice. This was after I'd done a fair amount of work with this car. So when we started, the scores were down around 20 or 30. And I was sanding on it until I got to a point where I believe this car was clean enough that we would be ready to go in for lab testing. So kind of pushing that general score up until I got to the point where I think this thing is clean. In blue, you can kind of see I was tracing the vehicle speed over time. So the driving that I did with this vehicle kind of looks, if you squint at it, kind of looks like that FTP 75. It's not exact. And again, I'm not looking for exact grams over exact miles on the exact cycle. I'm looking for the emissions signature. Now, I did take raw measurements on this thing. I do get to see the carbon monoxide, and I do get to see the oxides of nitrogen. And I obviously also, in the background, I'm getting lambda. And then I can check OBD. So I can see, is the mill off? Has it run the various monitors? And so if all those monitors are run, and I don't have a whole lot of detected NOx, and I don't have a whole lot of detected CO, and my overall score from the other map that we do in the background, it starts to get pretty good. Now I can start saying, okay, this is kind of giving me the confidence that I should think about showing up to a lab and paying to run a real test with cert fuel in the lab, in lab conditions. But I can run these tests over and over. When I know my first guess is going to be a little bit ugly, I might as well run it on the cheaper equipment and run it until I get an improvement here. So that's kind of where we're going. This is still work in progress. The hardware is evolving a little bit as I go forward. The data processing is evolving a little bit as we go forward. I don't know that it will ever really get adopted as a pass-fail standard, but boy, howdy, as an engineer, do I like this set of tools because I can set it up on a vehicle pretty quick and start getting some numbers really fast and know where to start sanding to make improvements. So going a step further, we get into the actual PEMS, and PEMS is portable emissions monitoring system. So AVL and Hariba are two big players in this market. Not surprisingly, these are the same guys that make the CVS column, so the constant volume sampling systems that you will see at the SEMA garage or ARB or EPA or all the OEMs. Very similar technology in a portable device that we can hang off the back of the car. Now you see this is more cumbersome than the mini PEMS. That's why the mini PEMS is a mini. This thing's kind of this big heavy device. So we're going to have at a minimum a trailer hitch or maybe a trailer behind the car to hold this stuff. But what it uses to make its measurements looks an awful lot like the stuff that they're using in the lab, because these now are 1065 certified. So they are using NDIR, FTIR, and FID technology inside of them in different combinations to start getting actual concentrations and flow measurements combined with that to start getting grams per mile. So the PEMS is actually used in some certification work, both by the EPA and the EU, because they have on-road testing. And guess what they use for the on-road testing? It's this. Now, the big downside to this is, of course, the price tag, right? So we've added a zero by the time we get into one of these. I have not seen one of these in modern trim be under about 300 grand. And really, by the time you're done adding options to them, they're closer to about 500 grand. So they're expensive, but they are super accurate. And so if you're clean on this, chances of you being clean in the lab are really high as well. So the EPA uses these devices. There are some requirements that OEMs have to pass a steady state. They'll just drive a truck down the freeway, and they do what we call 9-bag testing. So there's 9 different mile-an-hour breakpoints that they run steady state on the freeway, and they're looking for oxides of nitrogen and carbon monoxide, and they kind of plot those, and they want you down below oxides of nitrogen and inside CO, and they want you kind of down at the bottom corner here inside the box. And that's your real world steady state. And they kind of use that to make sure that, let's say, pickup trucks, especially while you're driving down the freeway, they have a lot of wind resistance. Is this thing working really hard? Is it going into cap protect or fuel enrichment of any sort during normal driving? So that 9-bag goes all the way up to the normal speeds that we drive on the freeway. And they want you to be stoic. They want you to be clean on your tailpipe. They want CO2 and water coming out the tailpipe. They don't want oxides of nitrogen. They don't want carbon monoxide. This is how they test it. So it's pretty cool. And then in the European theater, they have what they call RDE, or real world driving emissions. And so they have a not to exceed standard, which means that their test driver puts one of these on the car and they just go out and drive. And they can kind of do whatever they want with the car. And no matter what they do, you should not go past X number on certain emissions. And this is how they measure that. Now, again, there's a lot of variables as we do this. This is not a lab. This is out in the real world. So we've got background emissions. You know, if we drive in Los Angeles or New York City, the stuff going into the air filter on the front of the engine is not exactly clean. It's not a laboratory environment. On top of that, we get cut in traffic, and we're sucking the exhaust off the bus in front of us. We might be going uphill, downhill. We might get a good tank, bad tank of fuel from the local gas station. That changes things. So there's a lot of variables here. That's why in-lab 1066 testing is very controlled, and that's the ultimate pass-fail for us. But if you could run with one of these and you get really clean on one of these, then passing the lab should actually be easy by comparison. So that brings us to the lab. And the lab really is that final word in measurement. This is how the standard is written. So if we read CFR 40 and we start looking at, you know, what does the Clean Air Act require of us? And they say, well, you got to meet the standard. And CFR 40 spells out how the testing is run. These labs look a lot like it. So off on the left, you see a super awesome cell that is over at the Riverside CARB location. You see all those light bulbs on the ceiling. Those are solar array loads. So if you run the SCO3 test properly, like you can in that cell, they're actually putting radiant heat into the car, and you set the air conditioning on, and they're loading the air conditioning system with that radiant heat from the cell, in addition to the cell being pretty warm. And it's an all-wheel drive dyno. And oh, by the way, that room can be pressurized or rarefied to simulate elevation changes as well. It's a really cool room. That new lab is awesome. And they paid for that whole lab essentially from fines. So a lot of the Volkswagen thing kind of paid for that. And that top-notch equipment is what you see as a result of them spending that money. Really cool. I've been in a lab that looks just like that at General Motors and Ford as well. They've got all that stuff. This is testing to the absolute letter of how the requirements are written. So if we're an aftermarket company, we want to get our EO, we run in a facility that looks like this. Again, as long as it's third party and they're impartial and they take their measurements properly, your tailpipe number is below the magic threshold, pass or fail. The only downside to this is these systems are incredibly expensive, right? It's millions of dollars per test cell and big maintenance costs to keep them running. And so that means that somebody else coming in to use it, your per test fee is going to be likewise kind of high. So again, I don't want to show up to a lab like this and waste their time with a vehicle that I'm not sure is going to pass. So I'm going to book well in advance, but I'm going to do my homework long before we show up there. So punchlines here. Let's get some general notes. I kind of looked at all these different pieces of equipment and measurement systems of how we could get through that gray area. And let's say we're a manufacturer, we know that our goal line is go get that EO. And that's great. I think every manufacturer should get that for all their parts that they're selling for street cars. That should be a no-brainer. Now, if you're an installation shop, you start falling in that gray area a lot more. And we don't want to get visited, right? We don't want the guys from the alphabet agencies showing up with badges and guns asking for the last 7 years of our business records. When they come, if you guys listened to Evan when he was speaking at SEMA years ago, he'd say, we go visit people and we ask for their emissions data, and they had nothing. Zero. So some data is better than no data. If you start using some of these equipment systems like I showed you today, and we start keeping our data and we store that data and we attach that data to each customer's file and we put it in the invoices and the supporting documents, well, now we've got something. So God forbid we actually do have an interaction with any of these enforcement agencies, at least we have something to share. We can show that we've been trying to do the right thing. If you have nothing, they're going to laugh at you and you're going to be in big trouble. But by showing that we care and actually going through some of these steps, number one, our work product should be better. So our cars should be polluting a lot less should anybody audit them. And number two, it kind of paints that picture of which way we're going. So that leads me to point number two. We've been using some piece of equipment, or hopefully pieces, plural. We want to know what clean looks like. So like I said along the way, if you're not taking gram per mile measurements in a 1065 lab, okay, great, but what does clean look like on your device? So if we've got OBD devices, of course, it means the mill should be off, all the monitors should have run. If I got a lambda sensor, well, it should be really close to lambda 1 most of the time. Okay, cool. But even that's not enough to catch it. What about a NOx sensor? Well, I could detect NOx with a 5-gas, I could detect NOx with the mini PEMs, I could detect it with a VMAS or a full-on PEMS kit. Okay, great. Just know what kind of concentrations look good or bad for the types of things you're working on. Best answer here is, before you modify the vehicle, run it through your normal testing process. See what it looks like. If you start with a Ford Mustang, see how Ford did. They're pretty good at it, as it turns out. You take a brand new Chevy truck, they test pretty clean. So let's see how the experts did this. They took the test RA and they got an A. Let's copy their homework and see if we can start from there. Now, again, if you're a manufacturer, go get that EO. Get SEMA certified, right? Getting common applications together, we can kind of pool our resources on this. We find that companies who go get EOs are less likely to get visited. So the guys who have no EOs and no work whatsoever, when the EPA decides to come check up and see what they're doing because they've heard about XYZ company making these things that they think might be defeat devices. If that company has a long list of EOs and they think this other thing was a defeat device, they're more likely to have a reasonable conversation with you versus you've never done anything before. And oh, by the way, back to number one, you had no data. So ideally, what we're going to do as a manufacturer is we're going to run ours all the way through the process. We're going to have a very well sorted combination, and we're going to sell that same combination over and over again. So we don't have to reinvent the wheel each time we do this. Now, I talked about this a little bit earlier, and we're getting back to what about the race cars? Race cars absolutely have a place in our industry. In fact, they're the cool, sexy part of our industry. Those are the guys who get to make lots of horsepower and loud noises, and they're allowed to. Now, we get to argue about the RPM Act and whether we're going to preserve race cars, even though they were born as VIN tag production vehicles. I firmly agree that if somebody is willing to pull the vehicle off the street and they're never going to drive it on a public highway again, and that car lives in the trailer and in the pits and on the racing surface, then we shouldn't be worrying about the emissions for those small number of vehicles that never get driven on public highways. However, we've got a lot of people who will be irresponsible. We don't want to be those irresponsible people. There is no way you're paying me to put off-road parts on your car that you drove into my shop. So if it comes in with a license plate on it, I am not cutting your catalytic converter off and sending you out with a test pipe on this thing. That is begging for enforcement. It is a slam dunk case for any enforcement agency. And the same goes for turning off a code or a monitor or logic. Let's say we turned off EGR. Just because we can do it with the keyboard, in the eyes of enforcement, that's no different than doing it with a Sawzall. So if we legitimately have a car that comes in and it shows up in a trailer like this Corvette up above, and maybe they've got numbers on the side because they've run a certain series in a certain sanctioning body, document. Write all that stuff down. So if we say Bobby Speed Racer showed up on Tuesday with Corvette number 99 that runs in NASA's series, and here's his logbook, now we can start saying, of course, so that if an enforcement agency were to ask me about that car in the future, I can prove that this is absolutely not a street-driven car. There's no license plate. It's not getting driven on the street. I took pictures of it in the trailer, coming off the trailer, going into the shop, and going back into the trailer when I'm done, right? And one of the most important lessons here is that last point is don't let the customer put you in a bad place. Lots of customers will come in, man, the guys on the internet said, just take those stupid cats off and, with the superchargers, you're going to burn them up. No, they can absolutely live. There's so many 500, 600, 700 horsepower cars delivered from the factory that somehow miraculously don't burn their catalysts up. There's no excuse for us in the aftermarket. We can make that work too, just like them. We're not any dumber than they are. We just have to spend the time doing it. And don't let a customer talk you into being lazy and taking the easy way out. The really sad part about this is the customer is probably not going to get an enforcement action. But as the installation shop, you guys are far more liable, and the fines get way bigger. They add a zero for the installation shop. And by the way, it's not always only civil. It can be criminal. So I'm in no hurry to go to jail just so that somebody else can get 10 extra horsepower. You're not talking me into it. So with that, we'll turn it over to some questions.